So good morning students. Today in CFD we will study what is grid and what is the appropriate transformation. So first of all, grid means what is grid actually and what is grid points actually. Now you see to derive that finite differences we have drawn this figure. So these points are called known as the grid points. Okay, so these discrete points are those grid points, that is ij, I plus 1 comma j, I plus 1 comma j minus. So these points are grid points, and if you look at this case, these are uniform. There is a distance between the 2 points are same. And what is actually grid? Grid means arrangement of those discrete points, these points, arrangement of these discrete points throughout the flow field. This is called the grid. And what is grid generation? Grid generation means determination of proper grid for the corresponding flow is called the grid generation. Means for different flows you have to draw the different types of grid and how you will represent this grid and what is a proper grid. That is called the grid generation, determination of the proper grid. That is, it is not that for all types of problems you have to use one grid. Okay, so determination of the proper grid for corresponding flow geometries is called the grid generation. Okay, that is clear. Now second times come what is transformation or what kind of transformation. Suddenly what is the transform? Generally what happens when you have to apply the finite differences, there is a difference equation, and what is difference equation? You are discretizing the partial differential equation in the algebraic form. Okay, so when you are using the finite differences or difference equation, your grids must be uniform. Okay, so that is the difference must be difference between the 2 points must be same. But if you imagine this case, this is the wing of an aeroplane and you are defining the grids like this. Now you see that some of the points are lies inside the wing, but you see in this portion there is no air. Airflow will be surrounding this portion. Yeah, this is the case. Now you see hardly there is any point on the surface of the boundary of the wing. So generally what happen, what we do actually in case of finite differences method, first we must know the value of the characteristics of fluid properties at the boundary. Then suppose you are defining the point at ij. Okay, at the boundary the known value is ij. Then from that ij you can find what is the value of I plus 1 comma j by the use of those finite differences. So the uniform grid in this case is not possible. So for that we have to draw what is the proper grid for that case. So you see this is the your wing of the plane. Air is flowing like this. Yeah, this is the direction. These are the direction of the air in the neighborhood of the wing of a plane. So now we are defining the grid like this. Suppose this is your one surface, okay, eta, and the perpendicular lines are those x. So there are two new variables. One is xi and one is eta. Now you see here the grids are defined. Grids means points. If you know the value of the fluid property at this point, you can find at this one, you can find at this one. Similarly, if you know the value of the property at this point, you can find this one, you can find this one. Okay, so now the question is, this particular grid, it is not uniform. It is a non-uniform grid. So for a non-uniform grid, you cannot use this technique. Okay, so what you do, we have to use some transformation between these two original variables x and y to the new variables xi and eta, so that the non-uniform grid of the physical space convert to the uniform grid of the computational space. This is the main objective behind the transformation. Again I am repeating, here we are getting the non-uniform grid, and for the non-uniform grid you cannot use this finite differences because they are based on the uniform grid. So you have to define some transformation of what? Transformation between original independent variables and the new independent variables xi and eta, such that the non-uniform grid becomes the ordinary grid. Now, for this lecture, it is not necessary how it becomes the uniform. Today we will just see the transformation. In the next class we will see how it becomes a uniform. So we transform the variable x, y and t. We have taken the two-dimensional case to a new variable xi eta in the transform space or the computation. Then we are using some simple calculations, very simple. Simple chain rule is applying. Okay. And some simple techniques, simple mathematics, simple partial derivatives and the chain rule. We are using some relation, that is first of all, you see here what we have done. We have written the del x, that is the differential operator with respect to x, in terms of xi and eta, two new independent variables, and these parts must be known after knowing the relation. Similarly, we have represented del y, that is the partial differentiation with respect to the second unknown, in terms of xi and eta, del t in terms of xi, eta and tau, and other parts are known after knowing the transformation. Similarly, here we have calculated second order differential coefficient operator in terms of xi and eta. You just see the calculations. You see all those unknowns operators are in terms of xi and eta to new independent variable. Next we have calculated for y. Yeah, this is the case. You can verify it, and you can do. I have given an homework, so you please verify this equation number 12. Similarly, as for the second order derivative of x and y, you can verify. And after verification, I have a homework for you. Please try to, listen my word, please try to replace the Laplace's equation of second two dimension in terms of this new variable xi and eta, and if you do that, then you try to represent the Navier-Stokes equation in terms of xi and eta. Okay, so with that I would like to conclude, but please do the homework, that is Laplacian equation in terms of new variable xi and eta, two-dimensional obviously, and similarly you convert the two-dimensional Navier-Stokes equation in terms of this new variable xi and eta.